Okay, so today we're in week 3 and we're talking about vector maps. And actually, since I didn't finish week 2, I'm going to use that same project until I get all the CV code in there and just add in some vectors stuff to it as we look through it. I already started pulling up different resources as I did not research resources. I'm starting with, I think, this handy dandy notebook from the Imperial College of London has um, a bunch of preliminary like math stuff you need to know so that you can read the math, because like this is the foundation of all machine learning, um, especially deep learning, as we're talking about tensors and trying to do the computing. A lot of that is like, how do you visualize a lot of this math, which I don't know. It's been so long since I've been over this, and then I have my manga book of linear algebra, which I might just read, because that would be a nice refresher. Um, then there's also FastAI for numerical linear algebra, right? And this goes into more details of like uh, the concept of broadcasting, but in the context of NumPy, which would be very useful to work through these again, um, so I can practice. And if you've never heard of this, is a good resource. Um, I also just tried to, um, we could potentially just go over the NumPy linear algebra API, but I don't think that's as useful if we're not doing the actual Python. I did find some other resources, but again, they're not as thorough as the one from the College of London or Deep Learning from Coders. So then I found this whole thing that I've never heard of, like LibriText. What is LibriText? I guess it's like an open textbook, and like writing it out. But I think their biggest problem is it's so weird. I mean, look at it, right? Ooh. So I guess I'm gonna yarn now every time I say something so weird. Um, so yeah, and actually, let me pull up my collab as well, because we've got to get through this. So we have to figure out how to get it to iterate over the folder when I can't actually use recurse equals true. And it seems like recurse equals true is by default, so it should by default loop through the folders. Um, so we're just gonna have to keep trying to get this part right so that I can load my data. But I don't want to focus on that. I want to get back to that towards the end of this week once we go through the math so that we stay on a semi schedule. I'm not going over, I think, all of this, because this is like the one from the College of London, the Imperial College of London. And this one is the one from the FastAI people, and how to do, the basics of a lot of the foundational stuff. And so part of me wants to go through their stuff because I've been through it before. But also, I'm wondering, just depending on where I want to take um, things, looking at just more deep into the linear algebra. Like when I was in college, I didn't I think actually I did pass linear algebra. It was one of the courses I did pass. College. Um, but okay. So again, I don't like videos. I don't learn by videos. I don't know. Everybody does videos. I really just want a well-written book, and no one does that anymore. So I guess let's just start at the beginning and work our way through. Again, this is the FastAI numerical linear algebra GitHub, and then the Compline Alge GitHub.io, which is the Imperial College of London. And they're in the middle of updating their content, but I'm fairly certain that it still be pretty solid on what it's teaching, even without the updates. So we're learning this again, or really just studying it and refreshing it, because it's the foundation of everything that we do, especially in the deep learning space. I feel like uh, a deeper understanding of this will go further. Whereas in machine learning, a lot of it's just so built in. A lot of it is checking the outcome. You're not really necessarily coding as much. But in deep learning, if you look at the GPU program, a lot of it is that understanding. So I thought it would be useful to go over the vector math and Python for the next week. So um, when we think through, just like I think with any code, really, we want to think through I'm blind. Um, we want to think through the speed, the accuracy, the memory use. How can it parallelize? Because it does take a lot of time. And the other reason I wanted to go over matrix, because I really wanted to study more into graph machine learning. I think that is going to be a very interesting field, and so I think I keep saying I think, but you need a lot more math understanding. I haven't seen any like packages just implementing graph machine learning anywhere yet. But I think, have a graph book I wanted to go through on the math on it. Um, so let's look at their examples. So we have a matrix vector product, right? So it gives the probabilities of moving from one health state to another in a year if the current health states for a group are these, which will be the percent of each health state. So you get this matrix, and this matrix shows 85 as asymptomatic. And then let's see what we're talking about. Let's see. So 85% asymptomatic. Then we have the other options of if you have AIDS, 15% die. And we go further. If we're talking about asymptomatic, 90% are asymptomatic, 0.1% that are asymptomatic die, 0.2 go into full-blown AIDS, and of that, 15% die. But if you're symptomatic, 0.5 go into AIDS, 0.2 die, and 90 stay in that symptomatic state. Maybe that's because they can get treated. I don't know. So what are we looking at? And we're trying to predict for 1 year. So how do we do that? And so this is a Markov chain. Where's this source? Okay, let's actually watch that in a different tab. Uh, uh, so basically, how do you compute that down? Is the question, and this would be the output. Huh. The answer is matrix matrix product. I don't know because I forgot matrix math and I'm not sure unless you're reducing it, like if you just multiply everything across. But that wouldn't give you 7.65 at the top if you just multiply it across. So I might have to pull up a video. Videos. Because it's not adding it. It might be subtracting it. Hold on. Let's see if it's subtracting it. Pull out a calculator. If it's subtracting it, I can do that. I don't know. 0.90 minus 0.07. And yes, I'm an American. I can't do math. They barely taught me how to speak English. No, so it's not. Still not that. In 12 months. So how do we reduce it by a year? What will be the percent in each state in 1 year? So this is the current. Huh. Oh no, I can't. I can't sit for that long and go through something. It doesn't work for me. So, okay, so they do. They just so we had two. Let me reread the problem again because apparently, well, we know I'm blind and I miss obvious things on a page all the time. So this is the stochastic matrix, and it corresponds to this. But then the current state. That's why you just do the transpose on it. Okay, we can do that. Um, where's the? Oh. My life is so weird sometimes in my head. Okay. Let's get another notebook. Let's make some of these smaller so I can. Okay. So now we just need to make an array. I mean a matrix. We're making a matrix. Okay. We are making a matrix. Um, Here we go. This would be 0.90, 0.07, 0.02, 0.01, and this would be 0, 0.93, 0.05, 0.02, and this would be 0, 0, 0.85, 0.15, Okay, and am I setting that up right? Yeah, so I just put it in an array like this. So then I get another one. This one's much easier. This is now going to be 0.85, 0.85, 0.85, 0.10, 0.10, and 0. So now we have those two, and they need to be saved to something. And we usually start with A and B. All right. So make sure I didn't screw up just getting those saved. Oh, yeah, I need to import it. Huh. Oh, this still needs to be wrapped in all together as a matrix inside of NumPy array. Okay, there we go. And then this is not an array, it is a matrix, so it needs 2. All right, so if we transpose them of the right size, yeah, that gives us the right number. And I want to make sure I understand what at does, because pi. Does it tell me what it does? I guess it's dot product. It might not be because I don't feel like that's dot product, but it might just be because my brain is thinking in math and not in code because they don't translate in my brain. But okay, that's fine. So let's keep going. So now that we know kind of what we're doing, we have this matrix, we have this matrix, and we want the dot product, I guess. And let's see if we can't get that answer. Okay. Let's do P equals NumPy array. Okay. Do 6, 5, 3, 3, 1, comma, 3, 6, 2, 2, comma, 3, 4, 3, 1. That gets us that one. And S gives us that is not right because shop 1 is going to be 2, 5, 16. One, 2.5. I know it doesn't necessarily matter, but um, okay. So we have those two. And let's see if this works. I might have accidentally transposed it when I typed it. Let's see. Input operand 1 has a mismatch in its core dimension. Yeah. It is matrix multiplication. Size 4 is different from size 3. So it's complaining because this has 3 and this has 4. So I guess I need to do it the other way. No, I did do it the long way. Oh no. Okay, I get it. I need to do it this way. Just as the table says, I totally did that transposition. Um, bread is so expensive. Nope, that didn't do it either. Okay, let's see. Not what I meant to do. Okay. Are you going to show me the answer? Actually, let me see if they put the answer somewhere else. Translating math to code. No fun. Actually, it makes my head hurt just thinking about it. Because math is code and code is math. It's like going from Spanish to English. Okay, so I don't have to transpose it. So this is what I'm not under. I can't map in my head, right? Like when to transpose, when to not transpose. Like this has 4 in each column, and this has 3 in each column. But there's 4 columns, right? And that's only 2 columns. And here, oh, that just hurt like a stinging buzz. Like, maybe I should do the math on paper first and then like type up my code so that I understand what it's doing. In like my mind, that takes so much time. Like, can you imagine having the code, having to write out every matrix just so that you can visualize it because you can't do it in your head? I said we'd make my brain get a big old headache trying to reproduce it. Okay, so this one had 1, 2, 3, 4, and this had 4. But here we changed that, but they're even, so. And multiplied. This was asymptomatic, and this was the row for asymptomatic. So you wanted 85 times the row for the asymptomatic row. So this one needed to be multiplied by that one, this one by that one, this one by that one, and this one by that one. So if I did that math on paper, then we'd have 85 times 90, right? Handy dandy calculator for Americans who can't figure out math. Times, yeah, that's 765. And if I do 0.07 times 0.85, and we only want it for staying asymptomatic, so you only really need it for this one. So if I do 0.10 times 0, it's not 0, it's 1. And then if I do point, oh, hold on. This should be 0.505. 0.05 times 0 gives me and that's 0 times 1. Wait, hold on, this is wrong. I'm doing the math wrong again. So this is symptomatic. And then symptomatic is this one, which is 0.10 times 0.93. But I didn't get 0.093. 15.25. Yeah, I think my brain wants me to write out all the math and then write out all the code. If I do 90 times 0.85, I get 7.65. Then I have to do plus. The rust on my math skills is fierce. Okay. But if I do that for the first one, I'm not going to get this. I'm pretty sure. Hold on. So if I do 90 times 0.85, that's 0.76, and that's the answer. But these are two different computations. So don't add this one like I would the other one. I would go this way. Nope. Okay. Let's get out a linear algebra math book. Oh man, my brain, it burns. I want the simplest. Get rid of math. Like, this is like trying to speak royal English, and I want slang. Man, what a long month. I guess there's really no other way to do it. My brain wants slang so bad, but I can't read that math book, not in my brain right now. Like I'm back in college, looking over my homework and going like, what? Uh, you know, I wonder if I forget we have these tools now. Um, yeah, we have tools now. Tools that didn't exist when I was in college. Actually, I wonder how that's going to affect like math teaching. Because if I could have done this when I was in college, I'm not sure how much I would have actually learned. Like if I would have went back and actually studied the problem to do it myself. I think we're going to lose a lot of genius to not understanding why things are the way they are. No, that is not right. What is that size? 1 by 4. Um, okay. That is going to be 5. Let's see if it can explain. Incorrect dimensions. So this is not correct. It didn't do it like that. Okay, if it didn't do it like that, what did it do it like? Did it do it like this? So 0.85, 0.10, 0.005, 0. It did maybe do it like this. Okay. Because this would be rounded up, right? Goodness. Where's it? Oh, it's over here. Silly me. No, this is not just rounded up. So in that case, I'm missing something here. Dot product. No. Um, I don't even get an option for transpose. Okay, so we put transpose at the beginning. Oh, please don't make me type that all over again. I think I'm going to have to type it all over again. Do they have like a history? Can I go back? Let me go back. Please don't make me type it over again. Okay. So we put pose here. You know what? I might be typing in stuff that it just cannot comprehend. Okay, well, that was a bust. I broke it. Well, let's try. What does the transpose look like? Maybe I can figure it out from there. Okay, so the transpose looks like this of that one. And transpose of this one looks cross. Okay, so if we do it that way, then we have, no, it doesn't matter because I did it. I do 0.10 times 0.7. I still get the same thing because if I do, because I just put the transpose in here. Yeah. So no, it doesn't help me out. Thank you so much for failing me, public school education. even if I take 0.7 times point, that's 0.07 plus 0.93 times 0.10. That doesn't make any sense. Okay, so apparently I really am thoroughly incompetent in mathematics again, because I haven't had to do or know any of this for many, many years. Let's Google. So yeah, even if it's 2 times 1 minus, well, that would be plus because it's all plus signs, not dealing with negative. So this all across every 1, 2. Okay, let's look at it that way then. 2, 1, and 0. So across everything in the one line. And according to Symbolab, if I transpose, then that's the same as all those zeros. Now, if I do 0.7, I need to not do this stuff in my head. Okay. 0.07 would then be times 0.10, but 0.93 would be times 0.05, and you add those two together. Let's see. Da 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 Nope. I still did it wrong when I wrote it down. Because it's 8, 5, 10, 5, and 0. Yeah. And if I take a row, and my row is when it's transposed 0.0793. And if it's not transposed because I typed it in differently, that would be 0.93, 0.05, 0.02, and then that would be 0. But then that would be nope, that's still not it. Okay, well, we have proven that I am very rusty on matrices, which is why I can't figure this out at all. This would be like that one up here, and this one would be like the other one. but it's not getting me 15.25. Wish there was like a package where it would write out the math for all of the matrix multiplication so that I wouldn't be screwing stuff up. I'll try one more time on the back of this paper and we'll just write out everything so my brain can. That, or I might need to start with the manga book of linear algebra, and just read it out loud to myself for the next 7 days, however many pages I can get through. If I transpose it, get 0.0900. Oh, 0.9. Sorry. 0.90000. 0.07. 0.93. 0.0002. 0.05. 0.850. 0.01. 0.02. 0.151. That's my new matrix. And this new matrix, if I transpose, doesn't really matter which way I put it, right? I'm going to get 0.85, 0.10, 0.05, and 0. Okay. And if I do 0.10 times 0.07, which is the same as 2 times 1. All right. Which would be the same as 1 times 1. If I did point. Then that should give me 15.25, but it doesn't. Which, if I it doesn't, no matter what you do to it. Yeah, it doesn't make sense. I don't know how we got there. And if I do just one more. Okay. Okay. Christina is the slowest person in the world. So it does make a difference. Um, so this looks like this, but the other one looks like the whole array as a row. And if I take each position by that, I wonder if there's like a whiteboard. Goodness, they can't ever just give me a whiteboard. I just want to draw. Do you have a drawing pen so I can demonstrate what took me forever to figure out? No. Okay. Maybe PPT. Okay. Let's draw. Of course. Goodness. Okay. Christina versus battery life. Okay. Let's try this now. So we're going to call I need a drawing pen. Okay. So this is one matrix, right? 0.9, 0, 0, 0, 0.07 and 0.93, 0, 0, and then it's 0.02, 0.05, 0.85, 0, 1, 0.01, 0.02, and 0.15. But the other one switches from a column to a row, and that's what I was missing when it's transposed. I kept thinking of it as a column, but it's actually 0.05, 0.15, 0.10. No, this is 0.0. Sorry, wrong numbers. Is there an eraser? I'm still doing it wrong. Okay. 0.10, 0.05, and 0. So I kept thinking of it as a column up and down, but it's not. Because you're going to take this whole thing by this whole row, and because these are zeros, you don't use those. And then you're going to take this whole thing by this whole row, which will give you the answers that you needed all the way down. So 0.85 times 0.90, the next one will be 0.85 times 0.07 plus 0.10 times 0.93 added together. And that's how we get the same thing that was in NumPy. And my brain officially melted on time. So epiphany, and now it's 7:00. I might need to start streaming longer. I might need to start streaming longer. Okay, tomorrow we're going to keep going down this path until my brain computes this. And actually, I think this will help a lot with GPU programming because my brain doesn't compute this because I don't need to know this on a daily basis. None of the data science I do, it uses it, but I don't have to know it to do anything with it. So tomorrow we'll pick up where we left off and hopefully get through more of this notebook now that my brain understands transposing again and what it means mathematically versus how it's going to appear in when I type it out in code. Because to me it looks like the same thing, but actually it's a column. The way it's typed out is a column, and you transpose it, it transposes into a row. So I guess in code, what it would need to look like instead for this one, this is a column, and this was a column, right? But it's actually going to be, how would you recognize a row? Each. Actually, that's really confusing. I guess you just have to keep it in your head. All right, I'll see you guys tomorrow. Thanks for tuning in. Oops, that camera wasn't on me this whole time, I bet. I keep forgetting about it.